Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. In this video, we're going to build two of the Apple iPhone wallpaper. I like these examples because they feature some really fun techniques we can use in Skia to build such example. So we have linear gradients, sweep gradients, shadows, transformation of origins, and interesting masking techniques. So the first one we're going to look at is this nice stripe background. So we have a linear gradient in the background, and we're going to draw the stripes on top of it, also using a linear gradient. And we're going to scale the stripes on the y-axis. And we can add some shadows also to distinguish between the stripes. From there, we're going to use a masking technique to make the stripes disappear melt kind of in the background. So we create a linear gradient that goes from transparent to black to transparent. And the black pixels in the mask will show the linear gradients, and the transparent pixels will show just the background. And finally, we can add a nice noise to give this fun grain effect. The second wallpaper is also very beautiful and is extremely easy to draw. So we draw a circle, cut it in half using the trim function. We rotate it by 30 degrees. We translate it along this new axis, and then we draw an angular gradient to the shape. But then, instead of using the center of the shape as the origin of the angular gradient, we're going to use the center of the canvas. So we're going to use the invert transformation matrix to go back to the center of the canvas. And we execute the same thing on the bottom half circle. And that gives us this really nice effect. So let's dive into VS Code. We are into VS Code here, and I have a boilerplate project which you can download from the video description in case you want to code along, and have my stripes. So it's an array of indices. So I have 9 stripes. So here I already have the linear gradient of the background. And I guess we can draw the stripes. So yeah, let's do it. So we have our stripes. And we're going to start by drawing a rectangle. And we are going to add, just draw a rectangle. And the rectangle, so we have 0, 0. The width, I think we have it here. So the width of the screen divided by the number of stripes. And the height is the height of the screen. This looks good, I think. We need to add maybe a key here. We can use the index of the rectangle as a key. So we see the black stripe. And they all need, so maybe I can let me think, translate, so I times the stripe length, which would be width. So now it's all black, that's okay. And I'm gonna add a linear gradient, so I'm gonna put it into a group. And we can add a linear gradient that starts at 0, 0. And end at 0 and height, height of the screen. The colors, I should have them here, perfect. Okay, that looks good. And let's see if we can differentiate the stripe by adding a shadow. So we're going to add, let's say, 0 on deviation, but then a blur, let's say, of 20. And the color should be black, which I think is a default, but let's have a look. I think I like it. Feels a bit strong, maybe. We'll see. Yeah. The shadow feels a bit strong, but we can, let's see, we can adjust when we finish the example, but now we can scale on the y-axis the shape. So maybe I can do it here. We're going to scale on the y-axis. So I'm going to use interpolate. Usually we use interpolate for animations. Here I just use it as a, we're not animating anything, but just a simple way to do linear interpolation. So we go from 0 to at the end at length -1. And here would be, in the middle would be length -1 divided by 2. Right, so here it's 8, and 8 divided by 2, 4. And as values we would have, let's say, we can choose, but maybe 1, 6, 1, I don't know. Yes, that's actually not bad, but the origin should be the center of the canvas. Yeah, that actually looks okay. Still think this is way too strong. Okay, let's see. And now we need, or what if I do? Yeah, I don't know. And yeah, I mean, we can play with it, but I guess we want it on both sides. So if I want 10 on both sides, I guess these would be the values. Let's see. But now I think we want the stripes to disappear. So we want to use a mask. So this is the shape, but we need to wrap it into a mask. So we have a mask element and the mask. So we're going to draw a rectangle and apply a linear gradient, transparent and black, to have the expected effect. So let's see. So this should be the full rectangle. And in fact, so let's say this works. Now I need to apply a linear gradient to it. So linear gradient, start at 0, 0, and at, let's say I do, just to play with it, right? We end at 0 and let's say height divided by 2, and colors are transparent black, just to see if the mask is working as expected. This might be working. Let me just go do transparent in the bottom to see. So yeah, seems to be working kind of, but yes, let's try to do it nicely. And I think, and here would be height, but actually that's good. But what I need to do, I think, is because this one is transformed, so this actually looks correct. I just need to transform the whole result. And I think that should be good. Yeah. Okay, I think that's fair. One last step we can do is to add a grain effect. So we can add a fill with a noise pattern. So we're going to use turbulence, and you can use frequency x equals 0, 1. Here I take a somewhat small value, just octave. I guess we can put anything. So here we can make it bigger, so it looks smaller. And we can usually, to make it blend nicely, I use blend mode soft light. So yeah, here we have a nice subtle grain effect like in the Apple wallpaper. So kind of a fun example because we have gradient masking using transformations, and that yields shadows, that yields like some fun result. Now we can look at the wallpaper number 2. So here, this is the second wallpaper we can look at, which is actually, I think, fairly easy to build. I wrote down some colors. Here, I trust that you will find even better colors. There are many examples of variants of this wallpaper you can find online. So, but I'm going to start with the background linear gradient. And we're going to do a diagonal. So we're going to start at 0, 0 and end at with height. And these would be the colors. Oops. Yes. So that works. So now let's draw, so we need to draw half of a circle. So let's draw a circle, but as a path. So I'm going to call it half circle, and we should have the center somewhere. So the center is, yeah, we've divided by 2, I divided by 2, and half circle is a Skia path. Yeah, I think that works. And we can do half circle. I think there's many ways to do half of a circle, but here I can add a circle at the center. Radius is width divided by 2. That looks good. Yes. And now we can do half of a circle by doing a trim. So we can trim half of it. Yes. And complement here, argument is false. So we have our half of a circle. And should we? So now I'm hesitating if we transform it or we put the sweep gradient on it immediately. But also maybe one thing we can do is to have the second half, so which would be, we're going to add a transform. We're going to flip it. So scale y is -1. So we flip vertically. But I think the pivot point should be the origin, so the center of the canvas. Yes. Okay. And maybe we can try already to use the sweep gradient. I don't know. But the colors, I have some colors here. Let's see. And so the center would be the center. I think that looks good. Maybe I can, and we need the start angle would be 0 and end would be 1/2 of it, 180. Okay. So let's put it also for the bottom gradient. Different colors. Okay. So here, should I do? So we are seeing the wrong half of the. So should I do 360? Yeah, looks good. Looks, we have the same situation here. So maybe 180, 360. Yeah, that looks good actually. That looks good. So now this is the fun part. So let's transform. So we are going to rotate by, let's say, pi divided by 6. And the center is, the origin is the center of the canvas. Yeah. Why is it a string? Oh, center. Okay. Yes, and then we translate it on the x-axis by, I don't know, we've divided by 2 now. Divided by 4. So this is good. Now you see the center of the, maybe let me do the transformation also first for the second path as well. Oh, okay, so we already have something here. So we can just add the scale -1. And we had already the origin, okay. Can remove this one and this one. And of course it's here, it's minus, and yeah, okay. And so now there is only one thing left to do, is to transform the origin of the sweep gradient, because here it's in the transformed coordinate space. Like if you use on the web, the Canva 2D API, it works exactly the same. So here what you do is, we have a transformation matrix here. You take the invert matrix, it gives you maps back to the original center. So I really need to, so on the web, you have a nice matrix API to do this with the DOM matrix. And here we are not even using the Skia matrices, we use the shortcut, so the transform API that we took inspired from React Native. And we don't have an invert function yet available. I should really make it available. Building such an example made me realize that this really need to be contributed to the matrix API. But we have something still like quite convenient we can do instead, is that the gradient accepts also a matrix property or a transform property. So we can just do the invert by manually reversing each transformation. So kind of convenient, but also not so explicit, because, I mean, let's do it first, right? So on the bottom half circle, the center of the sweep gradient will be moved to the center of the Canva instead of the center of the shape. So scale, this one we don't need to invert. So here we invert. So first we change the order and we invert the transformation. So this, yes. So now we're at the center of the origin. So very convenient that we can do this so quickly. But what I don't like about this is that it's not explicit. If you look at the transform, it's not explicit that this is an invert of this transformation. So convenient because we can do this quickly and it works, but also I'm like, this is a bit awkward, but gives me ideas to contribute, to update the matrix API in Skia. Now we just need to do the same here. So we need to map back the center point. So we invert the order of transformation and the parameter values. This becomes plus, this becomes minus. That looks good, but we have a small issue here. Because we eat, let's see if we flip, maybe, no. If we do 0, 180, yes, and then we flip to see the other side. Maybe if I put it here. Yeah, I think this looks good. Here, because of the transformations, it's a bit hard to master where the colors are going to end up, especially already if you do sweep gradient, start at 0 and at 180, like it's not so obvious actually where the rotation angle is. And then we apply all these transformations, but we can change the color, play with it, and hopefully like get to some fun result. And sometimes like not knowing what to expect, you get like these beautiful mistakes that where the result is actually kind of cool. Guys, I hope you enjoyed these two examples. They feature some really fun capabilities that are available with Skia: linear gradients, angular gradients, shadows, transformation of origins. We could also do the invert transformation and path trimming, so to build shapes very easily. And I hope that you'll find creative ways to use all these Skia primitives in your own apps, and maybe also build such wallpaper, but with more interesting maybe color schemes. And there are some also other Apple wallpaper that we should really have a look at how they can be built using React Native Skia. So I am looking forward to talk to you soon, and until next time, happy hacking.